So welcome to section 2, the Java programming language. In this section, we're going to take a look at the basics of the Java programming language, Java as an ecosystem, and some of the benefits we get from programming in Java. So welcome to video 1, Introduction to the Java programming language and its history. In this video, we're going to have, as you might guess, an introduction to Java as a programming language and a brief look at its history. So, what is Java? Well, Java is a high-level object-oriented programming language. It was released in 1995 by a company called Sun Microsystems. Sun has since been bought by Oracle, I think in the early 2000s, and Oracle now look after its development and release management. So, it's an object-oriented language, which means there's a very specific way of programming it, and we're going to look at how that works and what object orientation actually means in a few slides' time. One of the key benefits of Java is that applications are platform independent. So lots of programming languages obviously work on different platforms, but the way they run on different platforms depends on the implementation for that platform. So a good example of this would be C or C++. A C++ application written and developed for Windows would almost certainly not run in the same way as a C++ application written and developed for Ubuntu. And that's because C++ leverages operating system specific libraries and dependencies. And those dependencies either may not exist or may behave in a different way on different operating systems. And Java was actually one of the very first programming languages to solve this problem and to be able to give you a guarantee your code or your application would run in exactly the same way on Windows as it would on Ubuntu. And that's actually a really, really powerful feature and perhaps one of the biggest features that drove the adoption of Java to be perhaps arguably the most widely used language in the world. Other languages now that are becoming more popular, like Node.js and Python, for example, over the last 10 years, it's very hard to make an argument perhaps for any other language other than Java for being the most widely used and the most widely leveraged language in the world. So a couple of interesting facts. This is directly from Oracle. Java runs on 3 billion devices. So that's not just computers and laptops. It's also embedded devices, smartphones, DVD players, things in cars, all sorts of things like that. All of these can run Java and do run Java. And as I mentioned, one of the main benefits of Java is that it's platform independent. So we're going to talk a little bit more on this later and how it works. But again, the key thing to take away is that Java code can be run anywhere with the same results. And that might sound obvious, but I promise you, if you've come from another programming language background, even something relatively modern like Python, something that's a language that's very popular right now, Python does not necessarily run the same way on every operating system. Java has a heavy emphasis on compile time checking, making it less error prone. So that means a lot of common programming errors can be detected by the compiler at compile time, meaning you can fix them before they get deployed to production. So before they actually run the application, the compiler can figure out if things are likely to break, and it's very, very powerful at doing that. Java is a strongly typed language, so that means data types are enforced. Now, you'll have noticed in the previous video in our little Hello World example, I added 2 integers together. And when I created those integers, I and j, I actually said to the compiler, these are integers. And of course, I assigned them integer values. So I was assigned to 10 and j was assigned to 15. Now, if I then try to change I to be a string, say my name, James, that would throw an error. Other languages will let you do this and they'll throw an error at runtime. Java is strongly typed, which means it throws that error at compile time. So it knows immediately that what you're trying to do is wrong. And another cool thing about Java, and one of the things that makes it really powerful and really scalable, is that it supports multi-threading natively out of the box. Now, a couple of key terms to be aware of when we're working with Java. So firstly, there's Java code. So Java code is the human readable code that's stored in Java files. This is what we write. So this is our int I equals 10, semicolon, int j equals 15, semicolon. Java code is the human readable code that we write that gets stored in .java files. Next, we have bytecode. So once the Java compiler, or otherwise known as Javac or Javac, when that runs, it compiles these Java files into bytecode. So this is machine readable. It's not human readable. So the output of a Java compilation step is some bytecode. Next, we have the Java virtual machine, almost exclusively referred to as the JVM. And this is the environment in which bytecode executes. And it's this tool that allows Java to run consistently across multiple environments. And finally, we have the JRE and the JDK. So the JRE, or Java Runtime Environment, is the downloadable package that most people will have on their computer that enables them to execute bytecode. So amongst other things, it contains the Java Virtual Machine, which is the environment in which that code runs. Now, what we downloaded was the JDK, or Java Development Kit. And the JDK contains everything that's in the Java Runtime Environment, plus things like the compiler and other tools that are required to develop Java applications. So, how does Java run? Well, as we mentioned, we start with a human-readable Java code. That's what we're going to be developing in this course. We then run the Java compiler on that Java code, the output of which is some bytecode. Now that bytecode then gets read by the Java Virtual Machine, which executes that code while interacting with the operating system. So there are a couple of steps in here. Java code gets compiled into bytecode, that bytecode gets executed by the JVM, and the JVM is sitting on top of the operating system. So why do we use Java and why do we care about Java? Firstly, because it's secure. Everything runs inside this JVM, so we're protected from tampering with system memory. The JVM essentially becomes a secure enclave or a secure sandbox in which our code can execute. It can execute consistently across operating systems and platforms, and we're isolated from low-level things like memory. So lots of security problems in applications occur because applications can leak memory into other parts of the operating system, because the operating system gives them control over the system memory. Running stuff in the JVM prevents this from happening. Next, it's simpler. It's simpler than lots of other languages. Because Java extracts away lots of things like explicit memory allocation and contains libraries for lots of complex problems like multi-threading, it means we don't have to reinvent the wheel each time. The Java ecosystem is really, really strong, and that means that we get a lot of stuff out of the box for free. Next, Java's multi-threaded. So most computers contain more than one processor core, but not all languages know how to leverage this. With Java, we can. Java can leverage as many of the processing cores in your computer as you like, and of course this allows you to run and execute your applications more quickly. And lastly, once again, Java code written on one operating system will run in exactly the same way on another. And this is not true for many languages. So Java is portable.